Hey everybody, this is Mr. Longo, and in this video we are going to cover half angles. So this is going to require you to obviously have your formula sheet in front of you if you need it, and also require you to remember a little bit about where certain trig functions are positive, negative, and well, let's just jump in and you'll see. So the first one says sine of 157.5, and your formula is for sine of a half angle. That's the one where it's the square root of 1 minus cosine theta over 2, all under the square root. And it's the plus or minus. So remember, when you're using this formula, this is something you have to keep in mind. The plus or minus just depends on which quadrant you're in. So sine at 157.5, that's in quadrant 2 somewhere, and sine is positive. So the plus or minus in the formula, you're just using the plus or minus based on the quadrant, okay? So we're going to have a positive square root value here. Now, the formula is 1 minus the cosine of theta. That's the full angle, not the half angle. So 1 minus cosine of, just double this and you get 315 degrees, all over 2. Again, this plus or minus in front, you're going with the positive one because sine is positive in quadrant 2. And now you need to remember the unit circle. So what is the cosine of 315 degrees? So 315 down here, cosine is positive down here, and you have a 45-degree reference angle, so it's root 2 over 2. So when you're simplifying, the next step is 1 minus the square root of 2 over 2, and that's all over 2. Now, a little trick to simplify this and make it easier is to just multiply all three terms by your denominator of any fraction you have. So we have a 2 in the denominator here. Just multiply all of these by 2. And if you do that, your next step is going to just be the square root of 2 minus the square root of 2 all over 4. And since 4 is a perfect square, you can simplify that. And our final answer is not that big of a square root, but the square root of 2 minus root 2 all over 2, because the square root of 4 is obviously 2. And that's it. You're done. So, is the formula ugly? Yes. But is it difficult to plug things in? No, not really. You just have to make sure, just like every other unit circle question we've ever done, you've got to be careful if it's positive or negative based on which quadrant you are in. Okay, so this next example, we have the tangent of 7 pi over 12, which means the full angle is 7 pi over 6. Obviously, you're just going to double it. So where is 7 pi over 12? 7 pi over 12 would be in quadrant 2, where tangent is negative. So the formula for tangent of a half angle is plus or minus a big old square root of 1 minus cosine theta over 1 plus cosine theta. But since we are in quadrant 2 for tangent, this one is going to be negative. Okay, now you're just going to plug some stuff in. So we're going to have 1 minus the cosine of the full angle, 7 pi over 6, over 1 plus cosine of the full angle, 7 pi over 6. What is the cosine of 7 pi over 6? So over here, cosine is negative. And you have to remember that the cosine value of pi over 6 is root 3 over 2. So this is going to be equal to 1 minus a negative root 3 over 2 over 1 plus a negative root 3 over 2. So all we did was substitute in the cosine of your 7 pi over 6. And now again, you want to use that trick. We're multiplying everything by 2. That's going to make some stuff disappear and make it easier. And now we have a negative, and this is going to give us 2 plus the square root of 3 over 2 minus the square root of 3. And there's nothing else you can do, so you are just going to leave it that way. Yes, these answers for half angles are going to be very ugly, but it means there's less simplifying to do. You don't have to worry about rationalizing your denominator or anything like that, so you're good to go. Just leave it like that. Next up is a little bit different. So this is telling you that if the tangent of theta is negative 4/3, and between 270 and 360, that means you are in quadrant, let's draw it, 4. Boom. So you have your theta, and tangent is opposite over adjacent. So that means your opposite is a -4 here, and your adjacent is 3 there. Now, of course, you need to find the hypotenuse using the Pythagorean Theorem. No surprise, this is going to end up being 5 because it's just a 3, 4, 5 triangle. But now that we know that, we are going to go find the cosine of theta divided by 2. So that means you need to think about where half of theta would be. If theta is between 270 and 360, you need to cut everything in half, and half of theta is going to be between 135 degrees and 180 degrees. So our half angle is going to be in quadrant 2, and cosine is negative in quadrant 2, okay? But here's the part. When you are using the formula, this one, cosine of half angles is 1 plus the cosine of theta. The cosine of theta is the full angle. So you're going to take your fraction values from the original quadrant that it's in. But then when you plug in your half values, you need to remember that cosine is negative. So for this formula, we are going to use a negative formula. And this one is 1 plus the cosine of the full angle. So the full angle is, the green one I have drawn here, cosine is adjacent over the hypotenuse. So this is over 3/5. And then, of course, it is over 2. Let's get rid of the denominator. So we're going to multiply everything here by 5. And that's going to give us a negative square root of 5 plus 3 all over 10, which of course will simplify to, that's going to be 8/10, which of course we can reduce to 4/5. So that's a negative square root of 4 over 5, and yes, that could be simplified to -2 over the square root of 5. And that one is actually very easy to rationalize your denominator. You can just turn that into -2 root 5 over 5. But since I haven't been making you do it for any of the other examples in this one, we can just leave it ugly just like that. Okay? So if you feel like you're ready to give one a try on your own, go ahead and pause the video and give number 4 a shot. But if you still need my assistance, let's go, because this is our last example for these notes. Cotangent is negative and cosine is negative. So first, you have to think, where is tangent negative? Well, tangent is negative here and down here. And now it says cosine is negative. Well, cosine is negative here, but cosine is positive here. So we have narrowed this down to starting in quadrant 2. So our original angle is, boom, here in quadrant 2. And tangent, as we know, is opposite over adjacent, which means cotangent is adjacent over the opposite. So we have a -2 over 1 here for our first part of the problem. Pythagorean Theorem, a squared plus b squared, 1 plus 4 is the square root of 5. And now we know what our hypotenuse is. So you have to think that this is the full angle. So that means the full angle is between 90 and 180. If you cut those in half, you get between 45 and 90, which basically means we are in quadrant 1 where everything is positive. So if we're finding tangent of the half angle, it's going to be positive because we are in quadrant 1. So this last example, we are using a positive square root of 1 plus, or 1 minus the cosine of the full angle divided by 1 plus the cosine of the full angle. So 1 minus the cosine of the full angle is -2 over root 5. So that's divided by 1 plus a -2 divided by the square root of 5. And yes, to simplify this, you are going to multiply everything by the square root of 5 to get rid of your denominator on the inside like this. And that is going to give you the square root of root 5 plus 2 over root 5 minus 2. And there is absolutely nothing you can do here to simplify. So again, you are done with a big, nasty answer. Anyway, that's half angles. Again, little tricky. Draw the original angle if it's given, and then make sure you figure out which quadrant it is for the half angle, and that's the only part you need for the plus or minus in the beginning. Otherwise, the rest depends on either the Pythagorean theorem or unit circle. That's it for this. This is Longo, and I'm out. See you, bye.